All right, so again, I'm on page 298 if you need to know that. Page 298. And the first hour we're going to spend just focusing on rational expressions. One more chance. Do you have any questions or comments before I get started? What up, Kylie?
You're going to do roll?
I called roll already.
How'd you do that? I was in here the entire time.
I did a silent roll call.
Okay.
Yes. Believe it or not, I do know everybody at this point, so yes. All right, here we go. Let's start with problem number 3. And everybody knows how to tell that that is a rational expression. The fact that it is a fraction and has variables in the bottom in the denominator makes it rational. Got that? So, the instructions say find all numbers for which the rational expression is not defined. We want to find all the values of x for which this rational expression is not defined. Now, in a sense, what they're asking me is, are there any values of x that are not allowed to be plugged in here?
That would mean the denominator ends up 0.
Right. That's what needs to be in your head when you're thinking about this is, well, I've got a fraction, and we know that the denominator cannot be 0. So any number that I would plug in for x that would make the denominator 0 is not allowed. Got it? So to answer this question, we're going to take the denominator and we're going to set it equal to 0 and we're going to solve for x. And then that'll give me the values for which the rational expression is not defined. And since we have a trinomial, we're going to try factoring. Can you read the signs? Both plus. I heard 5 and 7. Does everybody agree with that? And then once we have it factored, we're going to set each factor equal to 0 and solve. And moving the 5 and moving the 7, -5 and -7 are the answers. Everybody understand how that answers the question they ask? Let me read it one more time. Find all numbers for which the rational expression is not defined. And so we know that a fraction is not defined when you have division by 0. Right? Division by 0 is undefined. And so any number that makes the bottom 0 is not allowed. So these numbers are the ones that are not allowed. Questions? Now, don't we also do that process when we're looking for domain? Yeah, and so this is just another way to reinforce finding domain here. Okay, next problem, number 7. And the instructions say, find the domain. think that's what we were just hinting at, wasn't it? So this time it does ask me to find the domain. Write set builder notation and interval notation. So we're going to have to write it both ways. And so remember, when you're looking for domain, one of the things you're looking for is the restriction. Does a rational function have a restriction? Yes, the denominator cannot be 0. So again, we're going to take the denominator. And since we're looking for the restriction, I'm going to use the not equal to symbol, because technically the denominator cannot be 0. And then when we solve this for x, we'll know what x cannot be. All right, so how am I going to solve this equation? How am I going to solve that for x? What was that, Liz? Factor what? X out. Good. Do y'all see that they both have an x? And remember, in our factoring checklist that I gave you, factor out has to come first. All right, so if I factor out an x, that's going to leave me 3 minus x. And now I can set each factor equal to 0. And the first one is done already. X cannot be 0. And for the other one, I'm actually going to move over the negative x. Do you see, by moving the negative x, it makes it positive, and then I know what x cannot be. X cannot be 3. Anybody have any questions so far? Anybody? Questions? Okay, do you understand? Go ahead, Brandon. I'm sorry? Yeah, the 7 had nothing to do with it. Absolutely. Y'all understand that when you're talking about a fraction and we're finding the domain, it's the denominator we're concerned with. The numerator has nothing to do with domain, okay? You know what the numerator has to do with? Range. It'll affect the values y can be, but the denominator affects the values x can be. Got it? Now, if you stop right here, you technically have not written the domain. All you have right now are the restrictions. So to write the domain, we're going to say the set of all x such that x cannot be 0 and 3. And that is the domain in set notation. And does everybody understand that with this notation, it's basically saying, hey, x can be anything as long as x is not those two numbers. Anything. But what? That is the domain. It sure is. These are the values that x can be. So x can be anything but 0 and 3.
Number 3 is the domain also.
Say that again.
Number 3, the domain is also the answer. Is that domain also?
No, those are the restrictions. Because number 3, it said find all numbers for which the rational expression is not defined. And so what we're saying here, we're saying, hey, if x equal either one of these, then that's not defined. So it's a little bit different question. Y'all understand that, right? This one is saying, hey, what numbers can x not be? And this is over here saying, what numbers can x be? And this is set notation. Now we also need to write that in interval notation. And so remember I said x can be anything, right? Anything. Negative infinity to 0. Do I need a bracket or a parenthesis? Parenthesis. Keep going. Oh, well done. And if y'all notice what that interval notation says, it basically says that you can have anything from minus infinity to infinity as long as you remember to skip over 0 and 3. Y'all see how that says that? Anything from minus infinity to infinity, but skip over 0 and then skip over 3. Questions? Anybody? Okay, fine. We will move on then. Number 27. And what the instructions say this time, it says, well, it just says simplify. That's all it says, simplify. Okay, so I got 2 words for you. When it says simplify, you're going to factor and cancel. Got it? Factor and cancel. So what do I have in the numerator? What is that thing called? It's not an equation because there's no equal sign. You can say it's a quadratic expression, okay? But if I'm going to factor it, I have to identify what it is as far as one of our factoring terms. Okay, good. Liz, difference of squares. It is the difference of 2 squares. And once you identify what it is, then you should know the recipe to use. Right? Once you identify I'm making chocolate chip cookies, then we know the recipe to use for that, right? And then if you switch to oatmeal cookies, you got to switch recipes. So for the difference of squares, what are the signs? One of each. Remember, difference of squares always have different signs. And we're going to have T and T and 4 and 4. And that gets the numerator F'd up, factored up. Now let's F up the bottom. Let's factor it up. What is the denominator in our factoring checklist? It's a what? Oh, it's definitely quadratic. But as far as a thing to identify in our factoring checklist, what is this thing called? We got this one. This one was difference of squares. What is this one? What? Standard trinomial. There it is. I knew I could dig it out of you if I just tried hard enough. Whew, y'all need to go back and review that factoring checklist and look at all the identifications. This is a standard trinomial. It's a standard trinomial. And that means we know how to factor it, right? Can you read the signs? Yeah, they're both negative. We've got some T and T again. And the numbers that multiply to make 16 and add to make 8. 4 and 4. And now do you see we've got the entire rational expression F'd up. It's all factored up. Now is there anything the same top and bottom? And so those will cancel. Factor and cancel. Whatever's left is the answer. Now I do want to warn you, some people get cancel happy and they'll say, hey look, those T's match, cancel. Hey, those 4's match, cancel. Answer is 0. Right? Some people just go crazy and cancel. Reminds me of some of the drivers I see on the freeway. They just go crazy, violate all the laws. Yeah, by canceling the T's and the 4's, that violates one of the laws of math. Did y'all know that a fraction bar is actually a grouping symbol? Did y'all know that? And it says this must be done first, and then this, and then you can deal with division. A fraction bar is actually a grouping symbol. So if you cancel these T's, what you're saying, hey, I'm going to do the division before I deal with the numerator math. And you just violated the order of operations. Y'all got that? So do y'all understand what you can cancel and what you can't cancel? Now let me say it this way just so I know I've got it recorded on the video, okay? You can cancel factors, but you cannot cancel terms. So the T minus 4's, we were allowed to cancel those because they were being multiplied by something else. Factors are things that are multiplied. Is this T here being multiplied by the 4? So it's not a factor, it's a term. And so I can't cancel those because they're terms, not factors. Got it? Okay. Next problem. Number 39. All right, so do y'all see in this problem, now we have multiplication with fractions. Right, we got multiplication with fractions. And the instructions say multiply and simplify. But I want you to know for multiplication, my two words are still the same, okay? Even with multiplication of fractions, you're still going to do what? Factor and cancel. It's just we have more to factor now, okay? More fun for us. So what is x squared minus 16? What is that? Yes, difference of two squares. And so how is x squared minus 16 going to factor? Yes, plus 4 and minus 4, right? Difference of squares always have different signs. And what about in the denominator? There's just an x squared. Can I factor that? It's a monomial, right? It's one term. I can't factor a monomial. Okay, but I'm actually going to factor it. Okay. I mean, that's legal, isn't it? X times x is x squared, right? You don't have to do that. I just felt like it. Now, the next numerator. How many terms are there? Do they have anything in common? So what's the very top of the checklist? Factor out. So if they have something in common, you have to factor it out. What does that leave me with? And then in the second denominator, we have a what? A standard trinomial. And we need to F it up, factor it up. Can you read the signs? Did I hear plus minus? X and X. I heard minus 4 and plus 3. Everybody agree? Isn't 4 times 3 12? And 3 minus 4 makes minus 1. And we did need minus 1. So now have we F'd it all up? So factor and cancel. Is there anything the same top and bottom? Now do you see x minus 4, x minus 4, x minus 4? Do you see I got 3 of them? But when you cancel, first of all, it's going to be top and bottom. Secondly, it's got to be 1 for 1. Again, I see people on tests, they get cancel happy, and they just take out all the x minus 4s. They think they all cancel. But honestly, it doesn't matter which one of the x minus 4s you take from the top. It doesn't matter which one, as long as it's 1 for 1. Is there anything else that's going to cancel? Yes, we can. X and X. Cancel. And you know why that's legal? Because they're being multiplied by other stuff. So this X is a factor, and this X is being multiplied, it's a factor. And so we can cancel those legally. And now what's left? X plus 4, X minus 4. That's what's left in the top. In the bottom, we have an X and an X plus 3. So did everybody hear me say factor and cancel? Whatever's left is the answer. Y'all heard that? Oh, man, isn't this fun? Are y'all having fun yet? I'm having a blast. I think we should do another one. Number 57. And do y'all see the major difference in this problem compared to the last one? What's the major difference here? It's division, yeah. And when you have division with fractions, you've got to remember the KCF. Keep, change, flip. Yes, we are. Absolutely. I am going to do the 4-letter F word. Flip. I'm going to flip it. Flip it good. So what do you have to do when you have division with fractions? Keep, change, flip, right? And guess what we're going to do? We're going to factor on the fly. As I'm doing the keep, change, flip, I'm going to factor on the fly. Here we go. Difference of 2 squares. X plus 4. X minus 4, right? We've seen that, I think, twice already. In the denominator, standard trinomial. Can you read the signs? Both minus. X and X. And Marlene, did you say 5? Yay. 5. Keep, change, flip. So when I factor the numerator, it's going to end up on the denominator. And what can I factor out of 3x and 12? I can take out a 3. And what will that leave me with? And then in the top, we have another standard trinomial. Can you read the signs? Yeah, they're going to be different. X and X. I heard 5 and 2. Which one goes with the plus? 2 goes with the plus. 2 minus 5 is negative 3. Everybody agree? Did I lose anybody? Y'all see what I did there, right? Keep, change, flip. Factor as I go. Now it's all F'd up. That's 2 F words. Factored up and flipped up. Now we can cancel. What's going to cancel? I heard x minus 5. 1 from the top, 1 from the bottom.
X minus 4 on both sides.
1 from the top, 1 from the bottom. And is there anything else that'll cancel? Crap. Okay, so the answer is x plus 4, x plus 2. I heard that. That's good stuff. And if you're wondering, does it matter if the 3 goes in the front or behind? It doesn't matter. Okay? You could stick this 3 behind here. It's fine. Huh?
It's not a math law.
It's more like etiquette than a law. It's good math etiquette to stick that monomial out front, but it doesn't break the law if you don't. I hope it's not that picky. That's pretty picky. Hey, does anybody have any questions so far? Does anybody have their book open in front of them, the PDF book, and want to pick one to do? I don't want you thinking I'm picking easy ones. Y'all look through, and if you have the book open in front of you, and see if you see one that looks fun and exciting. How about 50? Oh, snap. Yeah. That's, 24b to the 7th. So that's 9a to the 7th over 8b squared divided by 12a squared over 24b to the 7th. And again, this is radically different than anything we've seen so far because all of the pieces are monomials. We don't have any binomials or trinomials. Everything is one term. And so that actually means super easy for you is what that means. It means all you got to do is KCF, keep, change, flip. And then you're going to go through and simplify. How many of y'all have the nice scientific calculators? I mean pretty much any calculator that'll work with fractions. You got a fraction button, it's a nice calculator, okay? I highly recommend, that's what I recommend since you have a calculator. Multiply 24 times 9 and make that your top number, and multiply 12 times 8 and make that your bottom number, and let the calculator reduce it for you. So whatever 9 times 24 is over 8 times 12, and then let the calculator reduce to lowest terms. And as soon as somebody has a reduced, what is it? 9/4. Did anybody else get 9/4 pushing the buttons? Yes? And you got 9/4? Awesome. I'm actually going to show that. Yeah, I'm going to. Oh, you did the A and the B also? Yeah. Yeah. Now, what I'm going to do is I'm going to go through and show you how I would do this if I was stranded on a desert island and I had to reduce this to survive, okay? All I have is a stick and some dirt, okay? And I can do math in the dirt. Here's what I would do. I would say 12 goes into 24 how many times? 2. So I'm going to reduce 24 and 12, and 12 goes into both of those. And then 2 goes into 8 how many times? And then this is a 1, this is a 1, this is a 4, this is a 9. And the only numbers I have left are the 9 and the 4. And do 9 and 4 reduce? No. So 9 times 1 is 9, and 4 times 1 is 4. And that's how you can reduce it manually. Now let's do the A's. I've got A to the 7 over A to the 2. Which has more A's, top or bottom? How many more? And there's your A's. And then look at your B's. I've got B to the 7 and B to the 2. Which has more B's? Top or bottom? How many more? Now, do y'all understand when I say which has more, that's telling me where they're going to end up at. If the top has more, then the B's are going to end up in the top. And then when I say how many more, that's the exponent.
It's kind of like you're canceling them out.
It is.
If you have 7, you're going to take off the 2 because there's 2 on the bottom.
That's exactly what we're doing, yeah. Yeah, if you wanted to, could you say, hey, B to the 7th, B times B times B times B times B, and could you write 7 B's? And B to the 2, B and B, right? And then you could cancel, and you'd have 5 left. You could cancel them 1 for 1, okay? Or, like you did in the back, you said it's just subtraction, right? So 7 minus 2 is 5. 7 minus 2 is 5. You could do it that way. That's done. Anybody else want to pick one to do? Anybody else got the book open and want to pick one?
I'm a visitor too.
You're just a friend, though? You're not a relative? Okay. I just saw your shirt. Should have worn my Captain America shirt. I'm ready. Liz or Marlene, y'all seem to be looking at the book there in front of you. Y'all got one you want to pick? Come on now.
We can move on.
What?
I don't have the book. This is really crazy.
Okay, something really crazy.
Like something I wouldn't be able to do without a math teacher.
Is it on the test?
You could ever come up with.
I'll do my best, okay? But I'm going to stick with something from the book, if that's okay. Because usually if I make them up myself, they tend to not work out so good. Okay, we'll try number 62. And keeping Marlene in mind, because she said, is it on the test? And so we got to keep that in mind too. All right, 62. How about that? That looks pretty crazy, and it's got some stuff in it that we haven't factored yet today. Okay, so first things first, I see division. What does that need to remind me of? Yeah, KCF. As soon as you see the division sign, we got to remember we got a KCF. Keep, change, flip for the people just coming in or the visitors, okay? And we're going to factor on the fly. As we're doing the KCF, we're going to factor on the fly. Now, if you look at the first numerator, can you tell me what that is? Cubic thingies, okay? But it is the what? Sum of two cubes. Sum of two cubes. And since it's the sum of two cubes, I'm going to need to write out what the cubes are. So what three things make 8y to the third? 2y? 2y, 2y, and 2y, right? And then what three things make 27? Remember, it's got to be three of a kind if it's a cube. Are y'all okay with that? 2y, 2y, 2y makes 8y to the third. 3 times 3 times 3 makes 27. And then we're going to factor. So the first ingredient is parentheses. And don't forget, for cubes, the first set of parentheses is a little bit smaller than the second set, because there's going to be more stuff in the second set. And then don't forget to throw in some soap. Remember soap for the signs. What does soap stand for? Same, opposite, always positive. Same, opposite, always positive. And do y'all remember that soap is only for cubes and dirty people? Remember the joke? Okay, so the signs are going to be plus, minus, plus. Same as the problem. Opposite of plus is minus, and the last one is always positive. And then the last step is fill in the blanks. So in the first two blanks, we're going to take one of each. We're going to take a 2y and a 3. Everybody remember how you get the first two blanks? Take one of each, a 2y and a 3. And then you're going to go 2y times 2y to get this blank. And then you're going to go 2y times 3. And then you're going to go 3 times 3 to get the last blank. All right, so 2y times 2y, 4y squared. 2y times 3, 6y. 3 times 3 is 9. And that's factoring the sum of two cubes. And then what do we have in the denominator? Right, the same thing, but it's minus. So we have the difference of two cubes. And you're going to have to come up with the cubes. So what three things make 64y to the third? 4y, 4y, and 4y. And what three things make 1? 1 times 1 times 1. And then we're going to use the recipe again. We've got parentheses. We're going to throw in some soap. Soap for the signs. Same, opposite. Always positive. And I heard 4y minus 1. That's taking one of each. 16y squared. 4y and 1. And y'all need to ask me if you have any questions about where that stuff came from. So for the signs. What up, Herman?
Where did the 4y come from?
Where did that come from?
Yeah.
Watch this. Are you watching? This times this.
Okay.
And what is 1 times anything? Itself. So to get this one, we go this times this, and then this times this for the middle, and then this times this for the left. See how cool that is? Da 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 da. So it's cool.
It's a squared minus ab minus plus b squared, right? That's the formula.
That's the formula. Yeah, some people had to memorize the formula back in high school or whatever. Yeah, so if this is a and b, then this is a squared, ab, b squared, right? Now, keep, change, flip. 16y squared plus 4y plus 1. Even though that's a trinomial, right? It's in the bottom and I'm going to flip it so it's going to be in the top. Did y'all see that I didn't bother factoring it? You know why? Because I've got one just like it over here. So what's going to happen to these two guys?
Cancel.
Yeah, those will cancel, so I don't have to worry about factoring it. But the 4y squared minus 9, I do have to factor it. 4y squared minus 9, that is the difference of two squares. And we know the signs are different. What makes 4y squared? 2y and 2y. And 3 and 3. 3 times 3 is 9. And now that we've F'd it all up, right, we factored it all up, now we can cancel. Let's start with the big guys. What else? 2y plus 3. What else? Is that it? Well, we're done. So the answer is 4y squared minus 6y plus 9 all over 4y minus 1 and 2y minus 3. That's the answer.
Do we not factor the 4y squared minus 6y plus 9?
You're right. And the reason we don't is because it can't. If I try the 3r's, since it's got a lead coefficient, what is 4 times 9? And you would have to have numbers that multiply to make 36 that also add and make 6, and those numbers are not going to exist. Okay? So we don't have to worry about factoring that because it doesn't. And can I give you one more little math secret? Would y'all like to have one more little math secret? If you end up with a trinomial that comes from a cube, that trinomial will never factor. The trinomial that comes from doing the sum or difference of cubes, you don't ever have to worry about factoring that, it won't. And does anybody have any questions so far? All right, so I'm done with that lesson.